All right, this is number 63 in section 1.3, and this is something that you've probably not ever done before until you get to calculus. We've rationalized the denominator before, but now when we look at this function, if we plug in 0, we're going to get an undefined function. So we can't put the 0 in and direct substitute like a lot of problems in this section. So what we can do, if you notice, we have a part of a difference of two squares pattern up in the numerator, so we are going to rationalize the numerator, and it looks pretty ugly at first, but when you see how it all falls out, you're really going to think, wow, they set these up that way. If you think about it, if the difference of squares problem says if you have two things subtracted and I were to have the same two things added, that produces a difference of two squares factoring pattern. So that's what I'm going to do. And if I do it to the numerator, I got to do it to the denominator. Okay, so I'm going to put this, I'm multiplying by 1 in this spunky form, and it's going to have wonderful things fall out of this. Because on the top, if you think of this as a minus b and a plus b, if you remember your factoring patterns, that when we multiply that out, we get a squared minus b squared. So what we get on the top is the square root of x plus 2 squared plus minus square root of 2 squared. And on the bottom, we have this x times this whole mess. So we're not going to multiply this out or anything. We're just going to write it right now. Now, if we go simplify the top, the square root of x plus 2 squared is just x plus 2. And then we're going to have the minus, and the square root of 2 squared is just 2. And these two things are going to cancel out, right? And on the bottom, we have all this. Okay. Now, if you think about what we've got here, this all canceled out, right? So it's just an x on top and an x on bottom, and x goes into x one time and x goes into x one time, and so what we end up with is this. And then plus square root of 2 on the bottom. Now, what we've done is we've rewritten this expression by rationalizing the numerator. And so we went through the work of all this just to do it. I could have gone off to the side and written the function out and done it. But what we want to do, but I just put it just kind of kept going with it because it was easier to write it here in this limited space. What I'm going to do now is go ahead and rewrite this limit as x approaches 0 here. Now, I can direct substitute 0 in, and I get 1 over the square root of 0 plus 2 plus square root of 2. And that is 1 over square root of 2 plus square root of 2. And square root of 2 plus square root of 2, I would have 2 copies of the square root of 2. And that would be the answer. We could rationalize it. It would be square root of 2 over 4 if we rationalized and got that out of the denominator there. So that's one of the new things in this section that you're going to see. Another problem that's important in this section, a lot of this in this section is just direct substituting. And if you can't direct substitute, you've got to try to rewrite the function. And in most of the functions we've had so far in this section, you're able to factor them and cancel things out. But 63 and 67, there was another little thing they show you how to do here. It happens quite a bit in the functions they give us. Let's say I've got this. I cannot plug 0 in because on the denominator, 5 times 0, if I plug x as 0 in, would give me 0. So I can't tell the limit from just direct substitution here. So what I'm going to do is I'm going to rewrite this. I'm going to say, okay, in order to do this, this is divided by 5 here, right? Sine x divided by 5x. What if I put a 5 here and a 1/5 here? Okay, I just multiplied by 1. Oh, I'm sorry, I'm overcomplicating it. Let's start this one over. I'm overcomplicating this. Sorry, sometimes my brain goes blank. You can understand, I'm sure. Okay, so limit x approaches 0, sine of x over 5x. What if I did this? If I were to say, I'm going to rewrite this as limit, I'm not going to multiply by anything, I'm just going to pull this 5 out, think about it as 1 over 5, so it's 1/5, and then I have sine x over x. Now if you look back on page 65 in your book, you'll see that the limit as x approaches 0 of sine x over x is 1. So we have 1/5 And all of this, if you look at the theorem on page 65, is 1. So this ends up being a fifth. So you have this kind of problem where you just kind of need, what you're kind of looking at here is this. It was sine of x, so I just needed an x on the bottom. Well, couldn't I just put that 5 out front, 1/5, just scoot it out? There's another problem related to this we'll look at. I'll find one like this. It would be like number 79. So here's a similar problem, 79. Limit as t approaches 0, sine 3t over t. Now, if I want to do this, the problem I've got right now is I've got a 3t here. And if I want to fit that sine x over x thing, it's not that it just has to be x, it's just whatever is here has to be down here. Well, I have a 3t here, but I don't have it on the bottom. So here's what I'm going to do to fix it. I'm going to manipulate it a little bit with some algebra. We're going to put a 3 here, and I'm going to come out front and multiply by a third, because a third times 3 would cancel out and be 1. I've just multiplied that expression by 1, but in doing that I have provided the 3t that I need to match up here now. So this becomes 1/3 of the limit as t approaches 0, sine 3t over 3t. And that's 1/3, and the sign of something over this argument is always just 1, so we get 1/3. Okay? Okay, so how would you do with something like number 81? Well, here's what we're going to do. We're going to rewrite this, and that's what you do a lot in calculus, is you rewrite things. This sine x squared, okay, so this is sort of the same pattern we've been seeing. We're going to rewrite this as sine x. This is the sine of x squared over x. Now, this, I kind of got a little confused by looking at this and thought, well, are they squaring the whole sine x? No, they would have had parentheses around the sine and x part, or they would have put the 2 like in between the word sine and the x. So what I need down here on the bottom, if I had an x squared on the bottom, I could do this, right? Can I get an x squared down there? Yeah, I could multiply by x here, which is, I could multiply the denominator by x. Really, that's 1 over x, isn't it? If I add something, I got to get it to cancel out. I got to multiply by 1. Well, here's what I'm going to do. I'm going to put the x over x. I'm going to multiply the limit by x over x, but the one on the denominator is here. Here's the one in the numerator that would cancel it out. But I'm going to carry that x along that's on the outside, and if you look what I have now, it's the limit sine x squared. The limit is x approaches 0, sine x squared over x squared, because x times x would give me x squared. These two match now. That means this whole limit becomes 1, so I have x times 1, because this x is still kind of floating around out front, which is x. So the limit as x approaches 0 of x would be, I could do this by direct substitution and say plug in x is 0, it is 0.